All right, now I'm going to show you today a different way to graph these. I think it will be easier for you. All right, and so we're going to use this little graphic organizer to do it. So if we look at the top, we have our reflections, translations, dilations, which are our stretch and compression. Okay, so you are familiar with those. What I want you to highlight here now is I want you to highlight the asymptote, the reference points. In particular, you're going to, these are the reference points, those right there. So you see we're going to do the same thing today. We're going to translate the two reference points we had talked about before, which is the y-intercept and the b value. And the domain, and range. One thing I want you to do on the domain is I want you to change that. Instead of doing this, I want you to do the negative infinity to positive infinity. Make it longer. Our 0, 3 right here. Let's put our 1, 7 over here. And then our 1, 7 is over here. The asymptote at y equals 2. Let's put that one in. This was if our b is 5, that signifies, again, that signifies growth, correct? Sketch that in. It comes up to the asymptote and then heads to infinity. In this particular function, what is the parent? 5 to the x. So the parent, put it down here, is the 5 to the x. So what is my first reference point for that? What's my A? 1. So my y-intercept is? So 0, 1. So that's right there. And then when x equals 1, what is your y? 5. That's, I think, right there. And our y-intercept for the parent, the horizontal asymptote is sitting where? At 0. So at x equals 0. Yes, thank you. So here's your parent. So what was the actual transformation? What was the actual transformation? What did the k do to this thing? Up, yes, how many?
3?
By, well, no, what's your K?
2.
So it was shifted up by 2. Did we move left or right? No. Did we stretch or shrink? No, we did not. So when you look at your transformed function from the parent, have we done this correctly? Did we take the parent and shift it up 2? Yes. Okay. Questions on that? Right. So you're going to find your A, the B, the H, and the K. and the horizontal asymptote. Now, what is the parent of this one? What's the parent?
4x.
Great, 4x. 4 to the x. Let me make that smaller. Okay, 4 to the x. Okay, so you can go ahead and find your a, b, h, k and your y equals. And then once you do that, you're going to find those reference points, those two reference points. Your first one is the h, a plus k. And remember your second one, we add a 1 to the h, and then we multiply the a with the b, and then add the k. All right, so do that. I do not want you graphing this, your new information, until after you have graphed your parent. So graph your parent first after you get all this information. Now then, I want you find those reference points. So your h is 4, and then you add your a of a half to your k of a negative 2. That's going to give you a negative 1/2. Okay. And then for your second reference point, so we're going to add a 1 to the 4, which gives us 5. Now, what happens when I multiply the a times the b? 4 times a half is 2, and then I'm going to add that to the k, which is negative 2, and so that would give me a 0. All right, so let's graph our parent. All right, what is the y-intercept for our parent?
0, 1.
Always 0, 1, right? And then when x is 1, y is 4, right? And our our horizontal asymptote, always at the x-axis. So if we sketch that in, here's our parent. Now, the new reference points. The new reference point at 4 and negative 1.5. So right around in there. And then your 5 and 0. Asymptote is at negative 2. So we're just going to sketch that one in. He's going to look like this. Okay, so let's describe what happened. What does the half do? Shrink. Shrink. What does the h do? Oops. Right 4. And the negative 2? Down 2. So we went right 4. Didn't get that in there. Now, let's see if we got this correct. So first thing we're going to do is we're going to apply the shrink. Okay, so I'm at that 0, 1. Where would the shrink put it at? How much did you shrink it by? A half. So the 0, 1 becomes a 0, half. Okay. All right, now then we shift it down how many?
2.
2. So that would be here and then here. And then we would go to the right, how many? So 1, 2, 3, come on, and 4. And there it is. So that one is correct. And then our second one up here. All right. If I shrink the 4 by half, what do I have? 2. So I'd have 2 now instead of the 4. Now we're going to do the same thing. We're going to go down 2, 1, 2. And then we're going to go right 4. 1, 2, 3, and 4. And there's your new one. And so that one moved there. Okay. So your new reference points were shrunk by a half, moved to the right 4, and down 2. Okay. Questions on that? Your first column is the decay. And your second column is the growth, which you just finished doing. The second column, you've just finished doing that. Okay? Now, remember that decay, that is when your B is less than 1 but greater than 0. Where in your growth, the B is greater than 1. The parent functions, they're the same for both decay and growth. The reflections are still the same when A is less than or equal to 0. The translations are all the same. Nothing changing there. The asymptotes are the same. Now we're going to look at the reference points. Over here, my 0, 1 went to an H, A plus K for decay. Was that the same thing with growth? Yes. So that is unchanged. Okay. Our second reference point for the decay is an H minus 1 and an A divided by B plus K. Is that one the same? No. Instead of adding the 1, we are now doing what? Subtracting the 1. And instead of multiplying the A times the B and adding it to K, now we're doing what? We're dividing the A and B before we're adding it to the K. All right. Domain. Domains are the same, and notice the ranges are also the same. So you're going to do the same thing you did with your growth, except for this one right here. That's the only different one. And how do I know if I have growth again? I mean decay. How do I know if I have decay? If my B is less than 1 but still greater than 0, right?
So it should be a decimal? Or a fraction?
Yeah, it could be a...
Because it's in between 0 and 1. So
Yeah.
would it be a fraction at all?
Okay, so let's graph our reference points at 0, -3, and then the 1, -1.5. Nah, 1.3, sorry. Asymptote was at y equals -4. This is a growth, so we're going to sketch that in. Okay, there's that one. Domain, what's the domain? Okay, and what's your range? Y is greater than -4. Okay, see if we can get this last one in. A is -1. B is, no, H. H is -2. K is 1. Tell me what were your points? What were your points?
-2, 0, and -1.7.
7, 1. Okay. And your asymptote was at y equals 1, right? Let me change color here. All right, see if we can get it done. All right, so we got our 1 here. Okay, on which one?
On the reference point, I got -1. I got -1.
-1 and 0? I don't know. I don't know. I can't find mine.
Yeah, it's -1. I added
-1 instead of the -2? Okay.
Instead of the 0, it's -1.
Oh, this one? Okay. All right, so let's plot those. So -2, 0. And -1, -1. Oh, whoops. All right, I'm in a hurry. -2, 0, -1, 1.5. So it's right there. All right, this was reflected, so therefore those reference points are below, right? And this. So he's gonna. What's he gonna do? This way? Is that right? Is that right? Did I get it right? Now I should have come further up. You should come closer. Get closer to your asymptote.
For these, we don't have